As climate change accelerates, rainfall is becoming less predictable and groundwater reserves are depleting worldwide. For billions of people, safe, clean drinking water is no longer guaranteed. And as shortages intensify, desalination, a technology once limited to the wealthiest nations, is entering a period of rapid expansion. Desalination plants on coastlines, water pumping through large pipes, engineers inspecting equipment. Between 2025 and 2029, global desalination capacity is set to increase by 25%, according to Global Water Intelligence. By 2029, the world could produce 150 million cubic meters of desalinated water per day, enough to supply the United Kingdom several times over. Segment 1. Why MENA leads desalination. The Middle East and North Africa, the driest region on Earth, leads the world in desalination. 16 of the 25 most water-stressed nations are here. Saudi Arabia alone plans to invest $80 billion in new desalination projects, consuming roughly 300,000 barrels of oil per day just to power these plants. Historical context. It was in water-scarce Kuwait, which has no rivers, that the first regional desalination plant was built in 1951. Today, MENA accounts for roughly 70% of global desalination capacity, with plants capable of supplying over 1 million people each. Jordan is planning a facility to meet the needs of 2.5 million residents along the Gulf of Aqaba. Segment 2. Environmental costs. It produces highly concentrated brine that can devastate marine ecosystems. Discharging this waste into the ocean in large volumes can create dead zones, where life struggles to survive. The brine desalination plants produce is just concentrated seawater. It might not be pleasant for fish near the outfall, but with proper design and dispersion, the environmental impact can be minimized. Brine concentration compared to natural seawater. Despite reassurances, the concern remains. The sheer scale of the global desalination boom means even small ecological impacts multiply across millions of cubic meters of water. Segment 3. Energy demands and climate implications. Currently, It accounts for 0.4% of global electricity consumption, but in Israel, that figure rises to 10%. Most plants rely on fossil fuels. In MENA alone, by 2030, desalination could require an amount of energy equivalent to twice the UK's North Sea. For desalination to align with a net-zero future, renewable energy is essential. Promises of solar-powered plants are emerging, but dependence on fossil fuels remains high in the Gulf. Reverse osmosis membranes are now 4 to 5 times more energy efficient than traditional thermal distillation methods. If adopted widely, these innovations could make desalination viable for lower-income, water-scarce nations. Segment 4: Expanding desalination beyond wealthy nations. Currently, desalination is largely the preserve of wealthy nations. But climate change threatens lower-income countries the most. Ghana, South Africa, and Namibia have already built their first plants. Senegal has just confirmed plans for its first facility. If energy efficiency improves, desalination could become a lifeline for the world's most vulnerable communities. Local engineer or government official at new plant in Ghana. Desalination is giving us the opportunity to provide water to urban populations that otherwise face daily shortages. The challenge is balancing energy costs with environmental sustainability. Careful planning is essential. Without sustainable energy and responsible brine management, desalination could solve one crisis while creating another. Segment 5: Field reporting by Nick Ferris. Nick Ferris reporting on the ground, interviewing local residents, inspecting water plants. This report is part of the Independent's Rethinking Global Aid project, led by Nick Ferris, London-based climate correspondent. Nick focuses on underreported climate stories in sub-Saharan Africa and the developing world, exploring how aid cuts and geopolitics influence water security. The global desalination boom promises water security for millions, but it is far from risk-free. The environmental costs, energy demands, and unequal distribution mean we must carefully consider who benefits and who pays the price. Desalination could bridge the gap between water scarcity and access, but only if technology, energy, and environmental stewardship advance together. The choice is clear. Desalination has the potential to provide water security for billions. But without careful design, sustainable energy, and environmental safeguards, it risks creating new problems in the fight against climate change. The future of water depends not just on technology, but on the decisions we make today.